Hello everyone, welcome to the another lecture of atomic structure class 8. Myself Suman Singh. So as you have seen in the last class, we have discussed about the Rutherford atomic model and its drawback, right? So from Rutherford atomic model and J.J. Thomson atomic model, and what we have seen that an atom contains what? Electron, okay, electron and proton, right? From J.J. Thomson experiment and Rutherford atomic model, we have came to know that and atom contains electron and proton. So what we have seen in Rutherford experiment, from there what we can conclude that the mass of an atom was in fact considered to be entirely concentrated within the nucleus, right, in the form of proton, as we have seen there. Let me draw here. So this is suppose nucleus and here this is an atom, okay, like this is an atom. So whatever the mass will be there, it will be here, right, in this here, because the electrons, the mass of the electrons, which is here and here, the mass of the electrons are negligible, right? The mass of the electrons are negligible, as I have already told you. So whatever the mass of an atom was in fact considered to be entirely concentrated within the nucleus in the form of proton, okay. And since the electrons were rightly thought to be negligible mass, right, but when it was discovered that nucleus had a greater mass, okay, then could be accounted by the proton alone, it was realized that there must be a third type of subatomic particles which was present in the nucleus, which has neither positive nor negative charge, okay. What I means to say that, let me say like this. Suppose this is an atom, okay. Suppose this is an atom, okay. So in this atom here, this is a nucleus, right? And in nucleus we have came to know that there is a proton, okay. So what we have calculated, when we have calculated the mass of this atom, we have found that it is coming greater than the proton, okay. Suppose two proton was there, so two proton was there, then mass will be, suppose two proton was there, then mass should be 2, right? But it was seen that the mass is coming 4, almost double. So just since the mass was coming almost double, so scientist has realized that there must be a third type of subatomic particles which was present in the nucleus. This is a nucleus, right? This one is nucleus. So in this nucleus there is a third type of particle is also present there, okay, whose charge is chargeless, which has neither positive charge nor negative charge. As we have seen that protons are what? Positive charge, electrons are negative charge, but the third particles which is present in this nucleus is neither positive charge nor negative charge, okay. Then James Chadwick, as you can see, then James Chadwick in 1932, James Chadwick discovered these subatomic particles called neutrons, okay. Since it has no charge, its mass was found to be 1.672 into 10 to the power minus 24 gram, okay. So James Chadwick has discovered that in an atom, okay, in an atom, suppose this is an atom and this is a nucleus. So nucleus, in a nucleus there is not there is only, there is proton, okay, positive charge, as well as neutron, means there is a proton as well as neutron is also present in the nucleus. And this neutron is what? It has no charge, okay, and its mass is almost that of proton or equal to proton, okay. Mass is almost equal to proton, as you can see. Now we will see the properties of this neutron. So when we talk about the properties of these neutrons, the mass of the neutrons is slightly more than that of the proton or equal to proton, right? As you can see here, the mass of the neutron is slightly more than that of the proton, which is 1.67676 into 10 to the power minus 24 gram, compared to 1.672 into 10 to the power minus 24 gram, right? And when we talk about the charge, it is electrically neutral. As you can see, electrically neutral means no charge. Okay. And now next is, atom of same element may differ in the number of neutrons, leading to the formation of isotopes. Okay, means what he wants to say that if we have two elements, two atoms, one is this and another one is this. Okay, so here proton in this, when we talk about this here, proton, this is also same, means let me explain you like this. What is the concept of this isotopes? Suppose we have this one atom here and another atom is here, both are same atom. Suppose this is an atom of chlorine. Okay, this is also an atom of chlorine and this is also atom of chlorine, but the difference is, then if the both are both are the atom of chlorine, then chlorine, if both are the atom of chlorine, then it has 17 proton, okay, and 17 electron, right? 17 electron and 17 proton, right? Here also 17 electron, 17 electron and 17 proton, right? But what he say, what he found that Jens Chadwick, what he found that there will be a difference in the mass. Okay, there will be a difference where when we will when we will calculate this, there will be a difference in the mass of this and this. And so what is the, why this difference is coming? Because of the neutron. Suppose in this new, if the number of neutron will be more here than this. Okay, so that is why there was a difference in the mass. Okay, and this type of element is called isotopes. Isotopes of each other means they are they are same. Here also they are chlorine, it is also a chlorine, and here also 17 proton, here also 17 proton, here also 17 electron, here also 17 electron. What the difference is? Where neutrons, here number of neutrons is less, here number of neutrons will be more. Okay, so that type of compound, or we can that type of element in which differ in the number of neutrons, leading to the formation of isotopes. Okay, if the number of neutrons is different, there is a difference in a number of neutrons of the same element, then there will be a formation of isotopes. Okay, so I hope you have understood, or we have got some idea about isotopes. Okay, so how we can define these isotopes? We can say like this: atom of same element. Okay, atom of same element having different number of different mass number. Okay, means element atoms of same element having same atomic number but different mass number due to the increase or decrease in the neutrons. Okay, different mass number, this will lead to an isotopes, or we can say that atoms of same element having same atomic number and different mass number is called isotopes. Okay, I hope you have understood this. Now this is one table is given, as you can see here, small table about electron, proton and mass. So now we have came to know that after a discovery of electron, we came to know that electrons whose symbol is like this, as you can see, and it has minus charge. Okay, which is minus 1.602 into 10 to the power minus 19 coulomb, and atomic mass is now 9.1 into 10 to the power minus 28 gram. Okay, and for proton, his symbol is this. Okay, and his charge is what? Plus 1.602 into 10 to the power minus 19 coulomb, and atomic mass is 1.6 into 10 to the power minus 24 gram. Okay, and for neutron, its symbol is this. Its charge is 0, it has no charge, and its mass is 1 point, again it is same as that of the proton, which is 1.6 into 10 to the power minus 24 gram. Okay, so I hope you have understood this. Now from the Rutherford concept, what we have came to know that we know that there exists a force of attraction between the particles with opposite electric charge, right? And thus this there is a force of attraction between the electron and the proton, which prevent which present within an atom, right? So it is expected that the electron being lighter, okay, charged, and in constant motion would generally lose energy and came close to the nucleus and eventually fell into it. Right, what we have discussed in the last class, we have discussed like this, right? Suppose this is a, suppose here, and here it is electron, here also electron, here also electron, here also electron, like this, right? Electron is there. So what we have seen, these electrons are, suppose we let take only one electron. In the last class what we have seen, suppose this is an electron here. So what is doing, what is happening here, this electron is moving here, right, like this. These electrons are moving, this electron is moving here, right? This electron is moving, right? So since electron is what, negatively charged, this electron is what, negatively charged, and this proton is what, positively charged, so there will be a force of attraction between these two. So what will happen, this, since this is moving, so one time will come, it will automatically come and it will collide with here, right? So this was the concept there, right? So but it is not happening like this. So why it is not happening like this, Rutherford was unable to explain, right? So this was the drawback of Rutherford experiment. Yesterday in the last class we have discussed this, right? So if the atoms are revolving around the nucleus, then electrons are revolving around the nucleus, and then one time will come when this electron will go and collide with the proton, right, or with the nucleus, but it is not happening like this. So what we can say, Rutherford could not explain the stability of the atom. Okay, it was Neil Bohr, another scientist name Neil Bohr. As you can see, their picture is given this. Electrons is revolving right here. Electrons is revolving here, and the one time will come, it will go and collide here, right? So it is not happening like this. So Neil Bohr, one scientist named Neil Bohr, he has explained the atomic stability. Okay, he has explained the stability of the atom. Okay, why it is not happening like this, that the atom electrons are not colliding with the neutrons. Okay, why it is not happening like this, this Neil Bohr has explained this. Okay, so what does Bohr atomic, which is also called Neil Bohr atomic model, okay, or we can say Bohr atomic model. Now we will see what is Bohr atomic model. So according to the Neil Bohr, suppose this is an electron, here electron, suppose. So what did he say? He says that according to his theory, Bohr atomic model, the electron revolve in a fixed orbit or a shell around the nucleus at a very high speed. Means what? Electrons will rotate in this fixed orbit, okay? The electron will rotate in this fixed orbit, okay? The electron will rotate in its fixed orbit with a very high speed, okay, in a fixed orbit, okay? It is not like this that it is not like this that electron is moving something sometime like this, sometime like this, or like this, or like this, like this. It is not like this, okay? Electrons are moving in a fixed orbit, okay? Whatever the orbit it has been granted for this, for them it is moving in a fixed orbit, and this orbit in which the electrons is rotating, okay, this fixed orbit in which the electrons are rotating, he given the name as shell, shell, okay, shell. So what does he say? According to the Bohr theory, the electron revolve in a fixed orbit or shell, okay, around the nucleus with a very high speed, okay? Now again what he says, that each of the orbit, this one is called, he called them orbit or shell, right? So each orbit, okay, is the each orbit associated with a fixed amount of energy, means the energy of this orbit will be fixed. Energy of this orbit is fixed, okay? Energy of this orbit is fixed in which the electron is revolving. Now what else he says, that the electron present in the cell, while it will neither lose or nor gain energy until some external force is applied on it. Means what? During the rotation, okay, during the rotation, means what? During the rotation of electron, during the rotation, if this electron is rotating, okay, if this electron is rotating like this, so during the rotation, okay, it will neither lose electron, neither lose energy, or nor it will gain energy, okay. As I hope you are understanding this will move in this fixed path like this, okay, but at the time of moving it will neither lose electron, or neither it will lose energy, nor it will gain energy, okay, right. Thus they maintain their position. It they means they will move in a fixed position. So as a result, what will happen? The inward force exerted by the nucleus is counterbalanced by the outward force of the moving electron. Okay. So what will happen? The inward force, there was some force, right, which was this nucleus was attracting this, right, with some force. So what will happen? Since this mm, the one force was exerting this was, right, nucleus was just means nucleus was just trying to pull that electrons, right. So this energy, or we can say that this force which was exerted by the nucleus will be counterbalanced by the outward force of the moving electron. Since it is moving, right, this electrons is moving, so the inward force, whatever the inward force is here, through which this nucleus is exerting, that much outward force will pull that nucleus away from the pull that electron away from the nucleus. Then what will happen? This electron will move like this, and there will be not any, means this nucleus can neither pull this electron towards itself, nor it will go away from the nucleus, okay. This will move in a fixed path. So this was um, so what will happen? As a result, the inward force exerted by the nucleus is counterbalanced by the outward force of the moving electron, thus preventing the electron from falling into the nucleus, okay, and making the atom structurally stable. I hope you have understood this. What is Bohr atomic model? Okay. Now, next is modern model of atom. What is the modern theory of atom? Okay, modern theory of atom. So when we talk about the modern theory of atom, so what is a modern theory? We will see. Okay, first of all, according to the modern theory or standard model of atom consists of subatomic particle. We know that. What is electron, proton, and neutron, right? Okay, and there are two structural part of an atom. One is nucleus, another one is orbit or a cell. Just now we have seen that, right? Cell and orbit. So the two part, one is nucleus, another one is orbit, okay. Orbit is what? It is an extra nuclear part present in the empty space that surround the nucleus. Just this one is what? This one is orbit, okay. This one is orbit, whatever the circle one it we are seeing, right. This one is what? This is an orbit, this is an orbit, this is orbit, this is an orbit or a shell, right. This one is orbit, okay. Now next is the nucleus is positively charged. As we know, the nucleus is positively charged, we know that, right. The nucleus is, everything is written here, you can see. We know that the nucleus is what? Positively charged, okay, and the center of the atom, and it is situated in the center of the atom, as we have seen there. Let me draw here. This is what? This is the nucleus, okay. It is in the center of the atom, okay. Now it consists of what? Proton and neutron, as we have discussed, right. It consists of what? One proton. It consists of proton and neutron, right. Next, the proton and neutron, collectively called nucleons, and the whole as a whole it is called what? Nucleons, okay, are held firmly in the nucleus by a strong nuclear force, and these are held together by a strong force which is called nuclear force, okay. and the entire mass, whatever the mass of the atom this atom has, entire mass is concentrated in this nucleus. Okay, because we know that the mass of the electron is negligible. Okay, as you can see, the entire mass of the atom lies in its nucleus, since the electron has a negligible mass, right? Now next is the positive charge of the nucleus is due to the proton present in it. Why this nucleus is positive? Because protons are present. As we know that protons are positively charged, that is why the positively charge of the nucleus is due to the proton present in it. Okay, now next is the proton remain unaffected. Why? Unaffected by the neutrons. Why these protons are remain unaffected by the neutrons? Because there is not having any electrical charge, right? Because neutron is what? Electrically neutral. That is why proton can easily exist in the with the neutrons, right? Now next is what? Orbit or shell. When we talk about the orbit or shell, so orbit is what? It is not like this. Suppose which is the one which I am drawing here time to time, this one, this orbit. It is not like a road where the electrons are moving. It is just imaginary. Okay, it is just imaginary path where the electrons are rotating. Okay, as you can see here, the orbits are imaginary path. Okay, traced by the electron in the empty space surrounding the nucleus. Okay, it is just not, it is not like a road where the circular road where the electrons are removing. It is not like this. It is just an imaginary path. Okay, and each orbit is associated with a fixed amount of energy. Okay, whatever the energy of this orbit will be different, this orbit will be different. And again, if one more orbit will come like this, if one another orbit is coming like this, the energy of this orbit will be, the energy of this orbit will be different. Okay, so you can see each orbit is associated with a fixed amount of energy. Okay, and therefore this circular orbit are known as energy level. That is why since they are having a fixed amount of energy, that is why we call them as a energy level or energy shell. Okay, now next is the electron revolve around the nucleus in this orbit. Okay, this one is nucleus, right? This one is nucleus, our positively charged. Okay, this one is our nucleus, and the electron revolve like this, right? Here, either in this orbit, either in this orbit, or either in this orbit. Okay, the electron revolve around the, as you can see, the electron revolve around the nucleus in this orbit. Okay, now next, the shell, or we can say the orbit, the shell or the orbit lying closer to the nucleus carries the lowest amount of energy. Means what? This one, since it is just next to the nucleus, right? This one, if we are talking about this orbit or this shell is just near the, very near to the nucleus, right? This one is nucleus. It is very near to the nucleus. Then the energy of this shell will be lowest. Okay, as you can see here, this one, the energy of this will be more, this will be more, but this one will be less. Okay, and the one which lies further from the nucleus carry higher amount of energy. Okay, and this one, the energy of this will be more, and the energy of this orbit will be less, because it is very far away from nucleus, this one, right? But this one is very close to the nucleus, so its energy will be less and its energy will be more. Okay, I hope you have understood this, right? Now next is, an atom is what? Electrically neutral, because the number of neutrons and number of neutrons and number of sorry, number of proton and number of electrons are same, so thus balancing the total charge of the atom. Okay, and what we can say, an atom is electrically neutral because the number of proton and the number of electron present in the present in it are same, thus balancing the total charge of atom. Just like we can say, number of proton is equal to number of electron, right? Now next sorry, now next is, while the neutral atom, when we talk about the neutral atom of an element, it has what? We have seen that it has equal number of proton and electron, right? When we talk about the neutral atom, it has same number of electron and proton, right? So this number of electron and number of proton used to vary from one element to other. Okay, this number of electron and number of proton will vary from one electron to other. Okay, so in this in the fact, what we can say, no two elements contain the same number of proton. Okay, that is why each element differ from other in its property. Okay, I will give you one example, then you will understand clearly. Suppose this one is sodium, okay, and this one is chlorine. So when we talk about this sodium has 11 proton, okay, and 11 electron, right? When we talk about the uh, chlorine has 17 proton and 17 electron, right? So as you can see, the number of proton here and the number of proton is different, right? That is why these two elements are different. Okay, these two elements are different. Okay, because number of protons are different, here also number of protons or electrons are different. So what we can say, we can conclude like this, that while the neutral atom, we can conclude like this, while the neutral atom of an element has equal number of proton and electron, this number itself vary from one element to other. Okay, in fact no two element contain the same number of proton, and that is why each element differ from other in this property. Okay, I hope you have understood this, right? So keep up to this. In the next class we will discuss about atomic number and mass number, right? Till that, thank you.